students, myself JV and Dr. Kiran Yadav. This session is basically based on nanotechnology and importance of science and technology. So I will primarily discuss about nanotechnology. So before understanding the meaning of nanotechnology, we should know what is nano here. Nano in the term nanotechnology stands for a nanometer, which is a unit of length in the metric system equal to 1 billionth of a meter. So nanometer is a unit of length and it is basically a very small length of the order of 10 to the power minus 9 meter. Technology is the making, uses and knowledge of tools, machines and techniques in order to solve a problem or perform a specific function. So let's see the definition of nanotechnology. Nanotechnology is the study of manipulating matter on an atomic scale. Nanotechnology refers to the constructing and engineering of the functional systems at very micro level, or we can say at atomic level. A nanometer is 1 billionth of a meter, roughly the width of 3 or 4 atoms. The average human hair is about 25,000 nanometers wide. So you can imagine by this comparison that how small a nanometer is. Even our hair is 25,000 nanometer wide. So let's see the history of nanotechnology. The first ever concept was presented in 1959 by the famous professor of physics Dr. Richard P. Feynman. Invention of the scanning tunneling microscope in 1981 and the discovery of fullerene in 1985 led to the emergence of nanotechnology. The term nanotechnology had been coined by Norio Taniguchi in 1974. There is a famous quote by a scientist which is there is plenty of room at the bottom, which describes the behavior of nanotechnology. So here bottom refers to the floor of the space where you are sitting, like the floor of the room or floor of a hall. So even in that space, or even if it is small, then even in that small space there can be a lot of things that can be done. So here is this quote, there is plenty of room at the bottom. So this is the meaning of this quotation. The early 2000s also show the beginning of commercial applications of nanotechnology, although these were limited to bulk application of nanomaterials. Silver nano platform for using silver nanoparticles as an antibacterial agent, nanoparticle based transparent sunscreen, and carbon nanotubes for stain resistant textile. So let us see the length scale, where we will be discussing three scale: macro, micro and nano. So in macro scale, the things which we can see comes like a person or an object like an apple, a bottle, a bag, anything, and these are all the things that comes in macro scale. Okay, then if the objects are less than 0.1 nm, then we call it as micro scale. Diameter of human hair comes on the micro scale. It has width of 75,000 nanometer. E. coli bacteria comes under the micro scale. Its length is 2000 nanometer. Then comes the nano scale, in which DNA or diameter of carbon nanotube and buckyball comes under this category. Like the DNA has a length of 2 nanometer. Carbon nanotube is 1.3 nanometer long. So these are very small structures. So let's see the timeline. Passive nanostructures, which are also known as first generation products, are dispersed and contact nanostructures. Example, aerosol colloids. Products incorporating nanostructure. Example, coatings, nanoparticles, reinforced composites, nanostructured metals, polymers, ceramics, etc. Then comes the active nanostructures, which are bioactive, and health effects. Example, targeted drugs and biodevices. Physiochemical active, 3D transistors, amplifiers, actuators, adaptive structures. Then came the third system of nanosystems, which came around 2010. Guided assembling, 3D networking, and new hierarchical architectures, robotics, evolutionary. Then comes the molecular nanosystems, molecular devices by design, atomic design, emerging function. These are the newest kind of nanosystem. Now let's see the tools and technology that are used. There are several important modern developments. The atomic force microscope, whose short name is AFM, and then scanning tunneling microscope. These are scanning probes that launched nanotechnology. Then techniques included in nanolithography are optical lithography, X-ray lithography, dip pen nanolithography, electron beam lithography. Lithography in MEMS context is typically the transfer of a pattern into a photosensitive material by selective exposure to a radiation source such as light. Let's see what are carbon nanotubes. Carbon nanotubes are allotropes of carbon with a cylindrical nanostructure. They have length to diameter ratio of up to 132 into 10 is to power 6 is to 1. Nanotubes are members of the fullerene structural family. Their name is derived from their long hollow structure with the walls formed by one atom thick sheets of carbon called graphene. Properties: these have highest strength to weight ratio, helps in creating lightweight spacecrafts, can easily penetrate membranes such as cell walls. Therefore, these are helpful in the treatment of cancer. Our electrical resistance changes significantly when other molecules attach themselves to the carbon atoms. Helps in developing sensors that can detect chemical vapors. These are some of the industrial companies that produce products based on carbon nanotube. Aston Bell Sports Inc., Zex Technologies. They use carbon nanotubes in electric cables and wires in solar cell and in fabrics. Now let's discuss about nanorods, which are also known as quantum dots. Nanorods are one morphology of nanoscale objects. The dimension ranges from 1 to 100 nanometer. They may be synthesized from metal or semiconducting material. A combination of ligands act as shape control agents and bond to different facets of the nanorod with different strength. This allows different faces of the nanorods to grow at different rate, producing an elongated object. In display technologies, because of the relativity of the rods can be changed by changing their orientation with an applied electric field. These are used in micro electromechanical systems and in cancer therapies. Nanobots are a different structure in the nano range. These are close to the scale of minus 10 is to power minus 9. Nanobots of 1.5 nanometers across, capable of counting specific molecules in a chemical sample. Since nanorobots would be microscopic in size, it would probably be necessary for very large numbers of them to work together to perform microscopic and macroscopic tasks, capable of replicating using environmental resources. These are used in drug delivery and biomedical instrumentation. There are two important approaches in nanotechnology. First one is the bottom-up approach and second one is the top-down approach. So let's discuss about both of these approaches. So first, the bottom-up approach. In the bottom-up approach, different material and devices are constructed from molecular components of their own. They chemically assemble themselves by recognizing the molecules of their own breed. Examples of molecular self-assemblies are Watson-Crick base pairing nanolithography. Second approach is top-down approach. In top-down approach, nano objects and materials are created by larger entities without bouncing its atomic reactions. Usually, top-down approach is practiced less as compared to the bottom-up approach. Solid-state techniques can also be used to create devices known as nano electromechanical systems or NEMS, which are related to micro electromechanical systems. So let's see the applications of nanotechnology, or these can be characterized as the applications of technology also. The various applications are in the field of energy, medicine and drugs, nanobiotechnology, nano devices, in optical engineering, in defense and security, in bioengineering, in cosmetics, in nanofabrics. So nanotechnology in drugs. Nanotechnology is mainly used for cancer therapy or for the treatment of cancer. This provides new options for drug delivery and drug therapies. Enable drugs to be delivered to precisely the right location in the body and release drug dose on a predetermined schedule for optimal treatment. Attach the drug to a nano-sized carrier. They become localized at the disease site, that is cancer tumor. Then they release medicine that kills the tumor. Current treatment is through radiotherapy or chemotherapy. Nanobots can clear the blockage in arteries. Nanotechnology in fabrics. The properties of familiar materials are being changed by manufacturers who are adding nano-sized components to conventional material to improve performance. For example, some clothing manufacturers are making water and stain-repellent clothing using nano-sized whiskers in the fabric that causes water to bead up on the surface. In manufacturing bulletproof jackets, making spill and dirt resistant, antimicrobial, antibacterial fabrics. Nanotechnology in mobile. Morph, a nanotechnology concept device developed by Nokia Research Center and the University of Cambridge. The morph will be super hydrophobic, making it extremely dirt repellent. It will be able to change itself from available light source using photovoltaic nanowire glass, converting its surface. Nanoscale electronics also allows stretching. Nokia envisages that a nanoscale mesh of fibers will allow our mobile devices to be bent, stretched and folded into any number of conceivable shapes. Nanotechnology in electronics. Electrode made from nanowires enable flat panel displays to be flexible as well as thinner than current flat panel displays. Nanolithography is used for fabrication of chips. The transistors are made of nanowires that are assembled on glass or thin film of flexible plastics. E-paper displays on sunglasses and map or car windshields. So this was all about nanotechnology and its application.